It's time for Defending and Commending the Faith with Joe Mott, inviting the atheist, agnostic, and skeptic to examine for themselves the evidence for the Christian faith. We are all limited by what we do not know and by the things we think we know but are not true. Dr. Joe Mott earned his PhD at LSU and was a distinguished math professor at Florida State University for 38 years, helping to write 3 math textbooks and authoring over 30 research articles in math. He is now the host of this radio program, Defending and Commending the Faith. Here is Joe Mott.
I'm in the process of demonstrating the 3 steps of the Kalam argument for the beginning of the universe. And I'm implying that God uniquely accounts for that beginning. The steps of the Kalam argument are these. First, whatever begins to exist has a cause for its existence. Second, the universe began to exist. A side note, the universe is not eternal. Third, therefore, the universe has a cause for its existence. In any valid argument, the truth of the conclusion follows logically on the basis of the truth of its premises. In the previous episode, I addressed the truth of premise 1. It is supported by, among other things, the law of cause and effect. In my generation, the second premise of the argument has gained major scientific support by the many confirmations of the Big Bang model for the emergence of the universe. While people still talk of the Big Bang theory, it is no longer doubted that the Big Bang actually occurred. That is, it is accepted as a historical fact. In science, the word theory does not necessarily imply that an idea is merely an hypothesis, an educated guess, if you will, but often it means a very solidly established and well-tested explanation of a body of phenomena. In that case, it is considered the correct theoretical explanation of the experimental and observational data, and then graduates to the level of being called the theory of the phenomena. Cosmologists think they have a fairly good picture of the universe since the Big Bang. What, if anything, may have happened before the Big Bang and what may exist beyond the bounds of the observable universe is the subject of much speculation and is not worthy of discussion right now. The generally agreed upon overall picture of what has happened within the universe since the Big Bang is sometimes called the standard model of cosmology. In this standard model of cosmology, space-time is described by Einstein's general theory of relativity. According to this theory, space-time is a 4-dimensional manifold, a mathematical object, which acts something like a rubber sheet. Think of the surface of a balloon. This sheet can stretch, bend, warp, and vibrate. Objects like planets and stars act as weights on this sheet, and so stretches and dimples the sheet downward. Einstein theorized that if the object was massive enough, it could pull the sheet infinitely down to form what is now called a black hole. William Lane Craig said of this standard model, "It can be confidently said that no cosmogonic model has been as repeatedly verified in its predictions and as corroborated by attempts at its falsification or as concordant with empirical discoveries and as philosophically coherent as the standard Big Bang model." In the book On Guard, Craig says, in a sense, the history of 20th century cosmology can be seen as one failed attempt after another to avoid the absolute beginning predicted by the standard Big Bang model. Science provides us with compelling evidence that supports the conclusion for the beginning of the universe. I give 7 main lines of scientific evidence, denoted by the acronym SHURGET. 5 of these I repeat from the book I Don't Have Enough Faith to Be an Atheist by Frank Turek and Norman Geisler. S stands for the second law of thermodynamics. This well-established principle indicates that energy is being gradually and equally distributed in all places. We know that the quantity of total energy is constant. That's the first law of thermodynamics. The second law states that in a closed, isolated system, such as our universe, entropy, that is, unusable energy, is increasing. Therefore, the amount of usable energy is decreasing. Unless energy is constantly being fed into the system, it will tend to run down and over extended time will be eliminated. Thus, a time will come, if nature takes its course, when all locations in the universe will manifest the same temperature, a so-called heat death, and all physical activity will cease. If the universe were eternal, this halt of activity would have already happened by necessity. There would now be no usable energy, and the system would have already been eliminated. But since those events have not occurred, the universe is not eternal. In the atheistic view, the universe is declared to be eternal, and it is affirmed that there is no act of creation to feed new energy into the system. Given those assumptions, my question is, why then has the universe not come to a state of equilibrium and suffered heat death? That event not having happened implies that the atheistic assumptions are false. H stands for hydrogen's abundance. Throughout the universe, hydrogen is being converted into helium through the process of nuclear fusion in the cores of the stars. This process is irreversible. A new hydrogen is not being formed in any significant amounts by the breakdown of heavier atoms. Astronomer Robert Jastrow explains, once hydrogen has been burned within that star and converted to heavier elements, it can never be restored to its original state. Minute by minute and year by year, as hydrogen is used up in stars, the supply of this element in the universe grows smaller. That's found in God and the Astronomers, pages 15 and 16. Therefore, an eternal universe would mean that there should be almost no hydrogen. Yet, in fact, we have an abundance of hydrogen. U stands for the universe's expansion. The years from 1915 to about 1930 were especially significant in regards to cosmology. In 1915, Albert Einstein introduced his general relativity theory. And by the end of the 1920s, cosmologists came to the realization that the universe was expanding. But this realization came about only after a difficult uphill battle. In the early 20th century, the common understanding was that the universe was static, more or less the same steady state throughout eternity. Einstein's field equations, a collection of 10 nonlinear partial differential equations in 4 variables, describes the basic interactions of gravitation and generalizes and supersedes Newton's gravitational theory. They provided a compact mathematical tool describing the general configuration of matter and space in the universe as a whole. The peculiar curvature of space predicted in his equations was quickly endorsed in famous experiments. And by the early 1920s, most leading scientists agreed that Einstein's field equations could make a foundation for cosmology. The only problem was that finding a solution of these equations, that is, producing a model of the universe, was a mathematical nightmare. Nevertheless, some models soon appeared. One in 1915 by Karl Schwarzschild, 2 additional models in 1916, one by Albert Einstein and one by Willem de Sitter. De Sitter termed his new model solution B to distinguish it from Einstein's solution A. One in 1922 by Alexander Friedman, and one in 1927 by Georges Lemaitre. The last 4 predicted an expanding universe, though later Einstein introduced a cosmological constant as a fudge factor to prevent the conclusion of expansion. The British astrophysicist Arthur Eddington, the secretary of the Royal Astronomical Society, invited de Sitter, as a foreign member of the Society, to produce an account of Einstein's general theory of relativity. His 3 articles in the Society's monthly notices introduced Einstein's theory to the English-speaking world. Lemaitre's model implied that space itself was indeed expanding, not just that the galaxies were receding into pre-existing space. Thus, the fact that the galaxies are receding apart from each other is explained by space itself expanding. But that, in turn, implied that the universe would have been much smaller in the past. As one looks back in time, the galaxies were closer together because there was actually less space. The farther back one looks, the smaller the distance between galaxies. In the words of Stephen Hawking, at some time in the past, the distance between neighboring galaxies must have been 0. Therefore, by extrapolating backwards, one can deduce that all matter in our universe would have been in the same locale a finite time ago. The best calculations give the age of the universe as 13.7 billion years ago. This is when the volume of space of the universe would have been either 0 or very near 0. In a paper in 1931, Lemaitre used the backward extrapolation to conclude that sometime in the past, where the space-time universe would reach a point where all matter was compressed into an unimaginably dense, hot mass, Lemaitre argued that the physical universe was initially a single particle, what he called a primeval atom or cosmic egg, which flew apart with incredible speed, often described as an explosion, giving rise to space, time, matter, and energy that came into existence along with the universe. Lemaitre's model formed the foundation of his theory, and his idea marked the birth of the cosmology which the steady-state astrophysicist Fred Hoyle later derisively labeled as the Big Bang. Thus, Lemaitre became known as the father of the Big Bang theory and cosmology. The expansion of the universe is now seen as one of the great scientific discoveries of all time, and Edwin Hubble generally gets the credit. But in my opinion, Lemaitre should at least be mentioned because he incorporated some of Hubble's ideas prior to Hubble's discovery. If you care to know more about the process of the discovery of these models and the people involved, consult Chapter 5 of Return of the God Hypothesis by Stephen C. Meyer, Chapter 1 of New Proofs for the Existence of God by Robert J. Spitzer, the article Big Bang Theory in Baker Encyclopedia of Christian Apologetics by Norman Geisler, the article The Expanding Universe on the website history.aip.org, and an article on William de Sitter on the website encyclopedia.com.
Thank you for listening to Defending and Commending the Faith with Joe Mott, a production of Wave 94 Radio in Tallahassee, Florida. If you have any questions or comments for Joe, please forward them to Doug Apple at Wave94 at this email address, dougapple@wave94.com. And be sure to join us every Monday evening at 6:45 p.m. on Wave 94 and subscribe through your favorite podcast app. Defending and Commending the Faith with Joe Mott.